see a couple new faces from last week. Just trading out on who's available today to come in person, and we've got a couple people still joining online, so I'll keep checking back and trying to update that. So for today, the lesson plan is basically the topics that are less common on the ACT, but we can't ignore them. It's not going to be many questions like it is with the geometry or even the parabola stuff that we did last time, but there's still enough that it's good to have it refreshed in your brain. And so for today, if you end up feeling like, I just can't do that, I need to focus my attention somewhere else, that's a valid strategy. But if you are aiming for the 36, you need to have it in your brain. And anything that we can do to just get you one more question at those upper levels of the test, that can be the difference between a 32 and a 33 is one question. So that's what we're covering today. We're going to start with sequences and series and then move on to matrices as we have time. So if you look at the page, I believe it's 8. Watch me say it wrong, but we'll start there. Nope, it's page 9. We've done all of those quadratic equation stuff last class, and this is the second half of the page. So, arithmetic series, arithmetic sequences. It's about the numbers in order, and then whether you're trying to find the sum of all of those numbers or just find what's called the nth term. Nth being the variable for, it might be the 5th term, it might be the 27th term. The nth term means that number in the set. So for the sake of ACT and most of the stuff we do, it breaks up into 2 categories. There is arithmetic, and coming from the word arithmetic, and then geometric. And this is one, again, that you cover in your standard class, but it's kind of one that falls outside of the standard algebra pathway. And so it's frequently done like, here's the lesson on it, and then you move on to other stuff, and it doesn't really connect to the other math as well. And so it tends to get walled off in your brain a little bit. So just looking at them, do you remember at all what this means? You do not have to memorize the names in order to be able to work with them. That's the good news. So sequences, series, that's going to be numbers in a row. For instance, 2, 4, 8, 16. It's the classic number series. 2 and 2 are 4, 4 and 4 are 8, 8 and 8 are 16. It's doubling each time. Or you could have 7, 10, 13, 16. What's going on with that sequence? You're adding 3 each time. So these are the 2 most common things we're going to see. This one is geometric. This one, arithmetic. So for the arithmetic sequence, what's going on is there's what's called a common difference. Which means we are adding or subtracting the same number. Versus the geometric sequence, we are going to multiply or divide by the same number this is called the common ratio. So again, I'm not huge on vocabulary for vocabulary's sake. Common difference, we know, that's the result of subtraction. You're subtracting two numbers and seeing how far apart they are. So the difference between 7 and 10, the difference between 10 and 13, the difference between 13 and 16. That is 3 over and over again. Common ratio, what's a ratio?
Like 2 to 1.
Yeah, it's the comparison of two numbers and it's division. And so when we're talking about the common ratio, we're talking about 4 divided by 2. 4 divided by 2 is the same as 8 divided by 4. It's the same as 16 divided by 8. It's comparing the two numbers, but rather than subtraction, because here we went up by 2, we went up by 4, we went up by 8. Here we're talking about the ratio, or dividing the numbers by what came before it. And so those are the two sequences we're going to see as we get going with this. So this is the background information. Then we're going to dive into problems, and we may get back to the formulas a little bit. But I'm going to talk to you about what's going on, and the what's going on will help you with the formulas, because memorizing formulas in no context, it's just shoving another thing in your brain. All right. So, I'm going to read it, not going to write everything. It says, in the table below shows the first 5 terms of an arithmetic sequence. Which of the following is a general expression for the nth term? So we have position 1, 2, 3, 4, and 5. And we have the nth term of 1, 5, 9, 13, 17. And so they have 2n minus 1, 3n minus 2, 4n minus 3, 5n minus 4, 6n minus 5 as the general multiple choice questions, what we're talking about. So if you look at the bottom page of this, it says for arithmetic series, this a sub n, or the nth term, is going to be a1 plus n minus 1 times d. So, if I said, find the nth term, would you have that formula memorized? I don't. This is cool, it's kind of nice, but I don't use it. So, look back to Algebra 1. Where was the thing that we had going up or down by the same amount over and over and over again? It's just a linear equation. Don't make this too hard. This is the first term, the second term, the third term, the fourth term, the fifth term. Y equals mx plus b. This is just a linear equation. Don't make it too hard. So, this common difference is the slope. We're changing by this same amount each time. You guys remember what b is?
Y-intercept.
It's the y-intercept. What x value is the y-intercept?
0.
0. And so the y-intercept is a sub 0. It's the 0 term. And so rather than having to do this specialized formula, remember how it works, all you have to do is go backwards. What is our common difference for each of these? What are we changing each time? 4. And it's positive 4 because it's going up by 4 each time. And so that's going to be our slope. Y equals 4x. All we have to do is find the 0 term. Go one backward before this sequence starts. What is the 0 term? -3, because 1 minus 4, -3. And so our expression, you can do plus negative, or you could just do minus. This is 4x minus 3, or in this case, 4n minus 3. Arithmetic sequences are just fancy, scary linear equations. They're not bad. And so if you need to know the 200th term, you'd plug 200. 200 times 4 is 800 minus 3, 797. So again, arithmetic sequences, not that scary. You can memorize this formula if you like, but I haven't. I teach math and I still just go back to a linear equation rather than trying to have the new specialized only in this case tool. I like multitaskers. All right, I'm gonna save that one for the end. So we're gonna jump back. Okay, Doris? Okay. So on this one, the setup is very simple. They give us a 12. They give us 3 blanks. And they give us 32. And the question is, what 3 numbers?
Yes.
Sorry?
She's downstairs. I'm in a class.
Oh,
I'm in a class.
online stuff, not a question for me. So, the question is, what 3 numbers should be placed in the blanks so that the difference between consecutive numbers is the same? So when we had the sequence, we just found the difference between 2 numbers and then checked to make sure it was the same on all of them, but we could find that common difference. What would the common difference be for this situation? We know 12, we know there are 3 blanks, and we know 32. How can we find that common difference? Because we are looking so that the difference between consecutive or numbers right after each other are the same. We don't want it to be a different amount each time, but we want to change that same amount and have these 3 numbers line up perfectly. So, first question. How big a number gap do we need to span? From 12 to 32, what's our total change? It's not a trick question. What's the difference between 12 and 32? 20. So we have a total change of 20 over the course of this sequence. So next, the second question. How many times are we changing? How many jumps are we making? 1, 2, 3, 4. We are making 4 jumps. There are 3 blanks, but we have changed 4 times. So all we have to do is take that 20 and divide it by the 4. We are making that jump 4 times. From 12, add 5, we have 17. Add 5, we have 22. Add 5, 27. Add 5, we land at our 32. And so when they have these fill in the blank problems, those are probably the most common sequence problems I see on the ACT. Yeah, there are blanks, but count the number of changes. It makes it a lot easier to look at what change we have had. Okay. This next one is going to be very similar to the first one. Again, they give us a sequence of numbers. They say the first 4 terms of an arithmetic sequence are 25, 21, 17, and 13. And they ask, what is the 20th term? If you can do it on your own, go ahead and leap forward. The 3 hints that I will give you are, what is our difference? What is a sub 0? And what is our y equals mx plus b equation? If you can find those 3 things, the 20th term should be pretty easy. I'm gonna try a different marker because that one's getting kind of hard to read. All right, so what is our common difference? Excellent.
That's fine.
So we acknowledge we are going down every time, so our common difference is negative. We're going down by 4 each time, so we are subtracting 4. What is the 0 term? What came before?
29.
29. If we are subtracting 4 each time, then this would be plus 4. 29 is a sub 0. So for our y equals mx plus b, m is going to be our change each time, or the slope. So we have negative 4. N is going to take the place of x because it's a sequence. And then we have, this is our 0 point, our starting point, the 29. So we have negative 4n plus 29. If we plug in the 20th term, we're definitely going to be in negative territory by now. 20 times negative 4 is negative 80. Negative 80 plus 29, negative 51, mental math? Okay. If you don't remember this, as long as you keep track, you could brute force this. And one of the fabulous things in the calculator is you could put 25 and press enter so that it's stored in your calculator as answer. And then you just have to put answer minus 4 and hit equals over and over and over again. And so if you get stuck on one of these, you can brute force your answer with the calculator and just calculate the terms of a sequence quite quickly. So if you get stuck, it's always good to have a backdoor method. But again, these questions, what's the common difference? What is the zero term? And putting it into a linear equation, y equals mx plus b, probably the fastest way to tackle the arithmetics. Our last question is a question 57 from an ACT test. And so the last 10 can be more complicated problems. At the same time, frequently that complication is more to do with the background than it is with how to solve it. So that's the warning that you're getting about this one. But it says a finite arithmetic sequence has 7 terms. Again, checking in on vocabulary. What does finite mean? Not infinite. Finite means it ends. So literally, this sequence only has the 7 terms. Just got 7 pieces. The first term is 3/4. And the question is, what is the difference between the mean and the median of the 7 terms? I can't do an and sign today. And this is an arithmetic . And I'm going to give you the options on this one. The options are 0, 3/4, 4/3, 3, and 4. So I'm going to give you a 10-second guess, and then I'll give you more time to work on it. So for 10 seconds, what would you circle if this were the last 10 seconds of the test and you just had to do something? So get that answer. Now think about it longer. All right. So asking you to be brave. What was your gut instinct, I have 10 seconds answer?
3/4.
You took 3/4? Okay. Anybody brave enough to tell what they said?
Is it 3/4?
3/4. Okay.
4/3.
4/3? Okay. So, the ACT has loads of questions like this. This one's just like the poster child of it, but I have an entire section of these problems that I have saved that I gave the label to random interesting. They do this amazing thing where they capture these mathematical concepts with questions that are multiple choice, but really they're getting to the heart of understanding the theory. So, arithmetic sequence. what makes it an arithmetic sequence? What is the defining characteristic?
Isn't it adding or subtracting?
They're either adding or subtracting, but it's always the same number. It's always the common difference. So we have no idea what they're adding or subtracting here. You could make up anything you wanted. But the important thing is that this is, I'm going to call it D. This is changing the same amount each time. 1, 2, 3, 4, 5, 6, 7. Yeah, I got the right one. So that's our arithmetic sequence part. Now we're getting into this idea of mean and median. So what is the mean of something?
Average.
We average it out, we add it up and divide. And what is the median of it?
Middle.
The middle. And so even without having anything written in here, we know that this is the middle. And what's happening with this arithmetic sequence is that because of this common difference, it's a uniform sample. The whole idea of mean is it gets dragged one way or the other by a larger or smaller number, trying to find where the true number middle is. But this is even. It's constant. It's like a uniform thickness. And so the mean is going to be that uniform thickness. The mean is in the middle, the exact same space, because there's no large or small numbers to drag it out of the same exact middle as the median. The mean and the median, difference between them is 0, because there's no numbers to pull them apart from each other. If you had 1, 2, 3, 4, 5, honestly, this throwing the 3/4 at you makes this a way harder problem. If they didn't give you the 3/4, even though it means nothing, if it had just been 1, you could have calculated this so fast. But because it delves into that fractions are intimidating moment, it stops you from just calculating it out. And it gets lost in the weeds. The difference between the mean and the median, when there's no number imbalance, they should be the same. The entire reason we have mean, median, and mode is because data is not nice and pretty, because it can get pulled by different statistical anomalies. But if the sample size is as even and regular as an arithmetic sequence, they're all gonna line up there in the middle. So that is that one. So, bonus question, if they throw that question at you, they like to recycle it every 8 tests or so. Now you know, arithmetic sequence, no difference in the median and mean. They're just the same. Not sure how much matrices we're going to get to, and that is okay. All right, so, geometric sequence. We have -2, +4, -8, and 16. And the question is, what is the 9th term? So again, what is our common ratio, or what would we even do to this next thing to find the 5th term? What is our pattern?
-2
Times -2. Times the negative causes this flipping pattern, and so anytime you've got a sequence where it's going positive, negative, you're multiplying repeatedly by a negative number. So we're multiplying by -2, and it asks for the 9th term. This is around the limit for me. To me, this would be faster to multiply out than it would be to formula. And so if I had this problem and I was asked for the 9th term, I would just be, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'd be saying 32, 64, 128. They're even the computer numbers. And so, how familiar are you guys with this, or is that a generation removed thing? Computers are base 2, and so I'm old enough that this was still a thing, that they would use these numbers all the time in like programming, or the Windows would say that it was 256 color. And so these ones are really familiar with me, but we're just multiplying by 2, by 2, by 2, 512, and then go back and double check and say, okay, negative 8, negative 32, negative 128, negative 512. And so for me, when it's around the 9th term, it's probably faster to still just multiply it. The actual formula, you're taking a sub 1, you're taking your ratio, and then you are doing it to the power of n minus 1. Basically, you're multiplying it one fewer times than the thing you need. And so our a sub 1 was negative 2. Our common ratio was also negative 2. And we're multiplying it, n sub 1, we're multiplying that 8 times. In this case, it actually would simplify down to negative 2 to the 9th, but that's not always the case. And so the more general version is here. But we are multiplying negative 2 times negative 2 times negative 2 8 times. All right. So here again we have, if the first and second terms of a geometric sequence are 3 and 12, what is an expression for the value of the 24th term of the sequence? And so here, they don't even want the answer, they want the expression, and so we're tapping into that formula. So again, you're going to take your first thing, and you're multiplying it times that common ratio, but you're multiplying it by 1 less than the number of terms you want. Because, hey, if you just wanted this first thing, the ratio, whatever it is, if you do n minus 0, it's ratio to the 0 power. Anything to the 0 power is 1, and we go back to that first term. Got people waiting. So, first question, what's our ratio?
4.
4. You take the second thing and divide it by the thing that came before. 12 divided by 3, our ratio is 4. What's our first term?
3.
3. Pretty obvious. And if we want the 24th term, we're going to be taking 24 minus 1, and that's going to simplify down to 23. And so since they asked for the expression that would give us the answer, that's where we're going to leave it. They don't calculate it out, they literally leave it as the expression that would give us that answer. So again, they are multiple choice tests, but they're really, really talented at asking the question so that you have to show some of the background rather than just brute force it the way that 9th term worked out. All right. If the 5th and 6th terms of a geometric sequence are 3 and 1 respectively, what is the first term? So this is the 5th, This is the 6th. How do we find the first term? Looking here, what's our common ratio?
Divide by 3.
Divide by 3, or 1/3.
6.
Not quite. So, in order to go backwards, we would be dividing by 1/3, or easier to see, 1 times 3 is 3, 3 times 3 is 9. And there's not really a formula way to get this answer. They don't give us something to work with there. And so you would have to work backwards. At this point, my mental math gives out, and I would be grabbing a calculator. From the multiple choice things, I can tell you, well, here's 27, and it's only here, so I need to go 2 more steps. It's definitely bigger than 27. The only one they give me is 243. So I'm assuming that is the correct answer. I still don't know what that intermediate one is. Something with 100, but
It's 80.
yeah. You were here. I was talking with Rakov. I took the ACT without a calculator one round. And it's moments like that that you just kind of have to say, that's the best one, and move on. But please, be better than me. Bring 2 calculators, 1 in case your battery dies, and 2, just plain remember your calculator. All right, so our last one with these sequences before we move on to the matrices is a little bit tricky. It says 4 numbers are in a sequence with 8 as the first term and 36 as the last term. And again, emphasizing the 4 terms, as much as possible, use these blanks to help organize your thoughts of this is the number of places I'm talking about. It will help your thoughts. But the first 3 numbers form an arithmetic sequence with a common difference of -7. And the last 3 numbers form a geometric sequence. What is the common ratio of the last 3 terms of this sequence? So we've got a lot of things going on here. The first thing that I would mark down is first 3 terms are an arithmetic sequence with a common difference of -7. So, what's 8 minus 7? And 1 minus 7.
-6.
So, now we are looking just at this last bit. And if you wanted to erase this or cross it out, now we're only focused on here. We've done our part with that part. We don't need it anymore. Now they just want to know what's the common ratio for these last 3 numbers. Can be as simple as, Thought somebody's answered. It can be as simple as, what do you need to multiply to get from 1 to -6?
-6.
-6. And again, if we multiplied this again, we would get to the positive 36. And so our common ratio for the last 3 terms is -6. This sequence up here as 8, 1, -6, 36 means nothing. It's not arithmetic, it's not geometric, it's just random numbers that they have given you. But because of the properties that you can focus on with these first three numbers, last three numbers, you can work out the pieces. So I call that ACT, somebody's just trying to be clever. Mixed results. Not my favorite problem, but just so you're aware, that is one of the ones that I found. So again, I went through about 7 different tests as I was assembling these practice problem collections. Those are all the sequence problems I found. They're not super common. It's just a matter of being familiar with them. All right. The second part to the obscure but still useful lesson that we wanted to work on is matrices. So, how many of you have done matrices? I'm not even certain if it's in Algebra 2 or Pre-Calc now. It kind of gets shuffled around. When I was first teaching, it was in Algebra 2. I think since then it's been moved to Pre-Calc for the most part. So, in general, unless it is something more theoretical and they don't expect you to actually calculate it, the matrices are going to stick to either 1 by 3 or 2 by 2. Those are the sizes that they actually use on the test. So we have 3, 5, -2, and 1. We've got -4, 5, 2, and 1. So, first question is, if I ask you to find element B1, 2, do you know what that is talking about? Okay. This is talking about the element or the piece of the matrix. B is going to come from this part. 1 is the row, 2 is the column. And so B1, 2 is talking about matrix B, row 1, column 2. This is the number 5. Is it matrix B, row 1, column 2? So that's one thing to be aware of. It's always rows, then columns. Other things to be aware of are the dimensions of matrices. This is matrix C, 1, 3, 7, 4, 2, 6, and D. So, the next thing that they would expect you to know for these matrices is, can you list the size of the matrix? And again, rows then columns. For the size, we're going to do rows by columns. So, 2 rows by 2 columns. Same for here, this one would be 2 rows by 2 columns. C would be 2 rows by 3 columns. What would the dimensions of D be?
3 by 3.
Almost.
3 by 2.
3 by 2. There's 3 rows, but there's still only 2 columns. So, the next thing to be aware of is multiplying matrices. The process for how to multiply them, we're going to talk about a little bit later, but this is just talking about, is it possible? And in order to multiply matrices, we were going to have, I'm going to say, and not x. X is a bad situation because we use the x there. So we're going to say A times B, having trouble writing this. We're just going to have to do an example. So, for C and D, we want to multiply C and D. This is a 2 by 3 and a 3 by 2. This is possible. It does work. The reason for that, in order for this to work, we need to have the inside dimensions match. And our answer is going to be the outer dimensions 2 by 2. From the looks I'm seeing, this is still kind of very new for you guys. Am I going too fast? Okay. Another example. Let's do B times C. B is 2 by 2. C is 2 by 3. Again, the inside dimensions match, so this is possible, and our answer is going to be the leftover outer dimensions 2 by 3. One of the most fascinating things about matrices is that they are one of the few multiplication things that the order definitely matters. Everything else in multiplication, it's commutative. We can just sit there and change the answer or change the problem order and it doesn't change anything. With matrices, it really makes a difference. Here we had CD. If we were to instead do matrix D times matrix C, now it's going to be 3 by 2 times 2 by 3. The inner dimensions match, but our answer would be 3 by 3 instead. And with BC, if we change the order, we would have CB. C is 2 by 3. B is 2 by 2. These don't even match. It does not exist. You can't multiply them. They only are possible when those inner dimensions match. And so one of the questions that I have is just asking, is this possible? So you don't have to do any calculations, you don't have to find an answer. It's just asking which one of these combinations does not exist, would not work. And so of the 4 that I gave you, CD, BC, DC, CB, CB would be the one that does not exist because those inner dimensions aren't matching up. And so, because matrix problems tend to be very tedious, they tend to be kind of drawn out, and the ACT is all about speed. You're answering 60 questions in 60 minutes. They keep the matrix problems very theoretical on the test. Just because if you were to multiply out B times C, it could easily take about 3 minutes. They're just kind of tedious. The matrix theory is a lot more about how it works. The actual calculation of doing it is left to computers. Without computers, matrices would be kind of a nice theoretical thing, but they're just so long to process that their true strength comes when you go past human brain computing power. All right, so knowing what the elements are, knowing if we can multiply them or not, that is some of what we're doing. So now we get into actually how multiplication works. And again, they like to keep things relatively small in the interest of time. So we have matrix A, 2A, and 3A. I'm going to go back to black because that brown is not coming up. So A, 2A, 3A, and we have 1, 0, and negative 1. So they ask us to multiply these out. First thing I'm going to do with this is, what are the dimensions of this first matrix? 3 rows by 1 column. Second, this one is 1 row by 3 columns. The inner dimensions match, so first of all, this is possible. And second, our answer is going to be 3 by 3. And so that's what I'd be writing out. I'd be writing out a matrix that says 1, 2, 3, 1, 2, 3, 1, 2, 3. 3 rows, 3 columns. The answer to matrix multiplication is always determined by the position of your spot. So this is the first row and the first column. What that tells us is we're multiplying the first row by the first column. The first row is A. The first column is 1. A. If I want the second row by the second column, I'm going to multiply our second row, 2A, by our second column, it's 0. And so the position on your answer tells you where you are getting that from the multiplication. And that is how I help keep it organized. So going very quickly, first row, first column, times 1. Second row, first column, 2A. Third row, first column, 3A. Second column, doesn't matter what we do, A times 0, 2A times 0, 3A times 0, 0, 0, 0. And at this point, this is again where you're using the multiple choice. We're looking at this one right here. They only give us 2 answers that have the right dimensions of 3 by 3. and only one of those answers has the zeros in the right spot. And so you are never obligated to finish matrix problems. You're just trying to get enough information to say, that's the right answer. Do not feel obligated to complete. Just get it close enough to, okay, now I have enough information to work with. All right. Number 60 is another one with multiplication being possible. And 15 is just multiplying by a constant. And then that one is just adding matrices. So we have time for one more before we dismiss. Would you like to have more does multiplication work problems? Would you like to just see multiplying by a constant, or would you like to see adding and subtracting matrices? Which one would be the most helpful to you? No making decisions for you? In that case, we should actually take a break on time, so I will let you go. Be back at 5 o'clock, so we've got about 4 minutes for a break for online as well. I believe we're going to come back to matrices a little bit more next time I teach, and then we'll move on from there.